Hello, in this, the fifth of our series of videos having a look at the GAGE framework, we're going to explore assets. How do we load bitmaps and music and things like that and make use of them within our games. As normal, we'll start off with a little bit of context just to set the scene. So you can see on the screen the broad sort of a collection of packages, if you like, that we have within GAGE. The particular one we're interested in this video is the Asset Manager, which again is linked from the main game class. And it's the thing that holds all of the assets, helps us load them in and makes them available to our game objects. By way of context, games, fundamentally, if you want to do a game, you're making use of a bunch of assets to visually and sonically make the game come to life. There's lots of different types of assets that games can use, depending if they're 2D and 3D. Just by way of some examples, music, sound effects, audio is one example. So these are either things that you can stream them in, or you can load in the clips into memory and then play them. Beyond that, if you're thinking about 3D games, you will have 3D models, which are defined as a collection of points linked into vertices, going into triangles. You can have textures then that are basically bitmaps that are meshed onto it. You can have animation data. So all the things we're talking here can just be raw data as well. So in terms of some skeletal files, defining collection of bones with some transforms and information about how certain animations play out. So these are all of the additional bits of data that are needed for games to come to life. Thinking a little bit more just in terms of 3D games, this ties into material effects. So you can see here on the screen, effectively it's the same model. We have a sphere and we have a cylinder, but they look differently in terms of not only the color, but also the surface detail. There's some that are smooth, there's some that have sort of a checkered pattern on it, and also how they reflect light. Some are more dull, some are more shiny than others. So whilst there may be the same 3D mesh under the surface, you can have different types of texture that define bump patterns or height maps or specular maps that you can use to define how the surface actually looks like when it's rendered, how it interacts with light and things like that. So again, with all things in games related, there's an awful lot to this, but we're just interested in doing a simple 2D game. So the things that we're interested, you can see here, we're mostly interested in using images. We'll load in bitmaps and we'll draw things from it. Sometimes we'll have one big bitmap containing several different images that we'll pick bits from, similar to the, if you like, the tile sheet you can see displayed on screen. Sound we'll use for sound effects and streaming music, and we'll also have some data files as well. JSON, what we'll typically use, maybe XML, could be basic text, could be raw binary, just depends what is being loaded in. So I'll show you a little bit of code first of all, just in terms of loading these different aspects in, and then we'll think about how we can manage these. So inside our GAGE package, we can go into Engine, down to I/O, and click on File I/O, and that's a collection. So this particular class here, it's not that long. It's responsible for offering us methods where we can load in different types of asset or resource from disk. So we have just walk through this, we have a context. So this gives us access to the particular app, the device that we're running on for our app to be able to access that. Our asset manager, that's one that Android provides. Again, that gives us a way of loading these things in. And if we do have some external storage, different location, we've got a storage for that. So when we create our file I/O, we're basically storing our app context, and we're going to get an Android file system I/O access through that context, and ditto for any of our external storage. Now, what we have after this then is really just a bunch of methods. So we got one for loading a bitmap. I'm not going to go through each of these in turn. You can have a look at them. So this one here, you bring in the location of the bitmap. You can specify the format of the bitmap. So bitmaps, you can have different number of channels, different sort of density for each of the channels, if it's an 8-bit, 16-bit color, if you have alpha values or don't have alpha values. So you can specify the type or your expectations as to how you're going to interpret the bitmap file. Bit there about just code for loading the thing in. There's a bit of trying and catching, because if you try and load something in, it may not be possible, it may not exist, there may be some errors along the way. As for loading bitmap, here we have one for loading in music in this particular case. So we get access to it, we create a new music instance. So for a lot of these things, I suppose you'll want to actually delve down into the actual class files, for example music there, just to see how the constructors work. Load sounds, this is a sound effect, not something we're going to stream, but just a short sound effect we can have in memory and then play whenever we need to play it. We have load font. So if we want to display text in our games and we want a nice fancy looking bespoke font to do that, we can load in a true type font to be able to use as well. Load JSON file. So JSON is a fairly nice, simple way of being able to specify data in a structured format that's easy to load, easy to parse, maybe not the most efficient thing in the world to parse, but nonetheless, and easy for a person to be able to understand and to edit. But there's we're loading in JSON, we've got a method here that will basically open the file up, read in the characters, and then give it as something that can be interpreted or put through a JSON parser. Other things here, the rest is really just for reading a file or for writing a file out, fairly basic stuff. And we also have access to preferences. So in your Android app, you can have share preferences or preferences, where sort of a simple store of sort of key value pairings, that if you want to remember settings from one run to another, or if it's a game and you have something like high scores that you want to remember one run to the other, you can store these within the preferences and then load them in the next time the app is run. So that's quite a straightforward file. It just lets you load in these basic different types, bitmaps, streaming music, sound effects, or JSON's the thing that we are assuming here. Now, when we load these in, and this is something to think about the management of it. So I've got a few pictures here of 2D games. And there's one thing about loading in a 2D game. If you load in different images and sounds, you generally tend to use and to reuse the assets that you load in. And you can see a few examples here. So this is sort of a top-down 2D tile-based environment. It's not exhaustive, but I've highlighted a number of locations. For example, you've got a water tile, and you can see that the pattern is the same. So this is one bitmap that's been loaded in and then been drawn many times. And the bitmap is a seamless one, in the sense you can put two of them side by side and they join up quite nicely. There's a number of tile overlays in this case, so you have some rocks or some tree stumps. And again, it's the same image. So we have one image that's loaded in, and depending upon what's on those tiles, we will make use of that image. Same idea with audio. If I have some background music, it might be a 5-minute clip. Whenever that 5-minute clip is finished, I generally will restart replaying it again and sort of cycle around. If I have a platform game where I've got a couple of different sounds for the character jumping up, anytime the character jumps, I'm going to have those things loaded in, and I'll just pick one of them and play it again. So you're making and reusing your assets, and it is very common. I'll give you a few more examples. Sort of an isometric style game here, drawn in a way so where you're just building things up. But again, if you look at, for example, the lamps or the actual walls, in terms of, here's a piece that's curved that's highlighted, you can see it's the same tile, so to speak. And another example, Spelunky in this case. So again, if there's lots of replication within this too. If you look at some of the decorative elements for the sort of the grass that's growing inside the cave system, or even just some of the actual tiles that are used in the cave system themselves, you'll see that they're the same. Now, this makes good sense because, well, rather, what it means that we need is we need to have some way of managing this. We don't want to have a setup where, if we have a tile-based map, like the examples that we've seen, where each tile loads in its own copy of the image that it wants. that would be very inefficient, massively inefficient. It would only make sense if somehow each tile was bespoke. It could change individually itself and would be unique. But in the vast majority of cases, you reuse these particular assets. And because bitmaps and music, they occupy quite a lot of memory space. It depends how compressed they are. But they use a lot of memory space, so you don't want to be loading in more than you need to load in. And this means then that within our games we need to have some way of managing our assets. In essence, to have a central pool of the assets, where if we load in the bitmap once, it's loaded in once, and is available for other objects to come along and to say, hey, I would like access to this bitmap so I can draw it. And normally we'll have an asset manager then that provides that service to, if you like, our game objects. So that's what we want to have a look at now inside the code. And it ties into a class called Asset Manager. Not to be confused with the Android Asset Manager, this is the GAGE Asset Manager. Asset Manager for holding loaded assets. And where do you find this? So this is found inside the main game class. If I search here, down in our managers and services, we define our asset manager. It's created whenever we're creating this particular fragment, and we've got a method for getting the asset manager out. So in essence, any game object, if it wants, it can go to the parent game and say, give me the asset manager. And it could use the asset manager for loading things in, or it could say to the asset manager, I think you've already loaded this in, let me have access to that please, because I want to display it or play it or otherwise use that setup. Have a look then at the asset manager. Just to walk through this particular class to see what it is. It defines a number of different types of asset at the top. So inside GAGE we have assets for bitmaps, music and sound, fair enough, fonts that we can do, and we also have animation data as well. So if you have an animated setup, that this will package together some of the animation data for that in terms of the frames, the duration you play it over, things like that. Thereafter, we basically have a collection of hash maps where we have a name and this linked into the particular asset we're talking about. So one for bitmaps, music, sounds, fonts, and animations. If you're refactoring this, if you had very many more types, you could just have a generic hash map where you had sort of a base asset class and you could store all of that in it. But here they're separately defined assets, which is simple enough. We have a file IO, which we can, as the class we looked at, we can use this for loading things in, and we've got access back to the parent game if we need to access anything within that. Whenever we create our asset manager, we store the game, we get a file IO from the games that lets us load stuff in, we create our various maps for storing the assets. What follows then after is basically a bunch of add or load and add or get methods. So different ways of accessing the content within the asset manager. So an add method here that if you give it each thing an asset name, so if you want to get a bitmap out, you need to have some way of accessing the bitmap. So this assumes that all assets have a particular name, and you can go to the asset manager, give it the name, and it'll give you back the corresponding asset, be it a bitmap or a music clip or whatever you have. But a method there checks to see, okay, do you have something with this? If you don't, you're returning false. If you do, you're actually putting the you're adding this particular one into our asset manager. So we can use this then to build up the asset manager. Likewise, if we're adding something in here, we can add in music, we can add in sound, or typeface, a font, or animation settings. So using these things here, we can add new assets into it. Method down here for load and add bitmap. So in this particular one, we pass in two strings. One is the name of the asset, how we can get it out, and then the second one is a location as to where we can find that bitmap. So this is the collection on file. So again, if it already contains that bitmap, we're not going to bother doing something. It contains an asset with that name, return false. Else we'll go to our file IO, we'll try to load in the bitmap. and if we've loaded it in, we will then try to return the thing in as well to check it can be added. Okay. Likewise, with a similar method for adding music or sound or a font or indeed an animation. So nothing more than a clump of methods there for adding in assets into our asset manager. In some instances, loading them in first of all before we add them. Next one we have down here is now this is a method that takes in a JSON file, and inside that JSON file there will actually be a bunch of assets that are named, and we'll load them in one in turn. And we'll see an example of how we do this when we have a look at the demo later on, but the JSON file has the sort of following format. You say list of assets, each asset has a type, a name, and then the location of that. And what we do there is try to load in the JSON file. If we load the JSON file in, we say it has an array, we step through that array and we work out, okay, well, what type of value is it? What's the name? What's the location of it? And depending upon the type, we call the load and add method. That's the ones we're just after having a look at above this. So this is a convenience method. It means that if you have a whole bunch of stuff that you want to load in, you don't need to load it in one after the other. You can put all the information into a JSON file that taps it all together and just say, here, load in the whole clump of this. If you go on down, we've got get methods then. So the methods all above are about adding. Now we have methods for retrieving things out of it because we want to load them in so that other objects can get access to them. So a game object could go to our asset manager and say, here, I need a bitmap. I'm going to draw the thing. Give me the bitmap that has this particular asset name. And if it contains it, it's then going to return that back out. Similarly, we can get music, we can get sound, we can get a font, we can get an animation file. So that's accessor methods. Now this actually brings us down to the end of our asset manager. This is a very simple asset manager. Bunch of load methods and a bunch of get methods. That's about it. There's lots of ways you could actually make this more fancy and more capable. Just go through a few of them because maybe you want to extend it in this way. One is in terms of introducing in threading so that whenever you're loading these particular aspects in, you can have worker threads that will load in your assets in the background. And a lot of games, if you are doing a lot of streaming, you might want to load these assets in before you think you need them, but do it in the background. The other thing this is actually missing is the ability to remove assets. So it kind of assumes that for the asset manager here, you can load in all of the stuff you need at the start. For large games, that is not going to be the case. If you have a game that has different levels, it would be very common to say at the start of each level, I'm going to load in the assets that this level actually needs. And then when you finish it and want to go on to a new level, you would release all of the things you've loaded in and then load in the new ones for the next level. So these would be additions that can be added into the class. Looking at how this all ties together, so we'll show you an example now. This ties into one of our MISC demos, and we'll do our asset demo screen. We'll just run this so we can get a bit of expectation as to what we should be seeing. So this was under here, it was under assets, and what we have under assets is a bitmap at the top. So this is a bitmap that contains several different sub bitmaps, if you like, several different images inside it, frames of an animation in this particular case. We have a custom font that we have loaded in where we're displaying bitmaps and fonts using that custom font. We have a single image that we've displayed in, and we happen to be rotating that image here. And we have another one that's been loaded in here, and we're applying a degree of a sort of a swapping between different ones, giving a bit of a color tint to this particular image that's been displayed. So we'll have a look at that demo just to see how we make use of A, the loading functionality for loading things in, and then B, getting access to these whenever we want to use them. So we have our asset demo screen is a type of game screen, so it's just going to be the screen that appears there. We've got our back button, which took us back, and then for this particular demo we had a number of bitmaps that were displayed. Back to the screen. So inside this here, we had our ship at the bottom, we had our arrow over here, and we had our sprite sheet at the top. The ship at the bottom rotates around, so we have a variable that helps us remember what rotation we should draw the thing at. And you can see, if I go back to it again, we have a degree of color cycling happening over here. We have a red tint, cyanide tint, a green tint, a yellow tint, and it cycles around this here. So in terms of the red, the cyan, the green, and the yellow, that's the array of colors that we use that we're going to then cycle around, and we're applying a tint to the bitmap. So when we're displaying the pixels, we will tint them with a particular color. Or if we don't, white would be the default. Just make the bitmap appear as the bitmap stored in the file. We have our constructor over here. It creates a back button. And it sets up some sounds for the back button, gives it a position, and so on. And also it says here are the images, or the names of the images that this one uses. So back arrow and back arrow selected. So back arrow is what it looks like when it's visible. Back arrow selected, whenever I touch on the button, it changes to a different color. So that's the selected image. Now, this class actually contains an assumption. It assumes that whenever I get around to calling this asset demo screen, that at some prior point I have actually loaded in my back arrow and back arrow selected. If I haven't done that actually, and I know that it will have because it's in the earlier screens, then this particular class has a bit of a brittle dependency built into it, because it doesn't itself load it in, it assumes that something else is going to load the thing in, so it introduces a dependency. Okay, now here's the, I suppose, the demo code for using the assets. We can see over here we get access to our asset manager by going to the game and saying, can I have the asset manager please? We're going to our asset manager and we're asking it to load and add in a number of bitmaps. So over here we're giving it the name Adventurer Jumping, which is the sprite sheet, and we're giving it in the second string the location of that. So that's relative to my assets folder, what I have here. And if I go into my images in the assets folder, I should be able to see Adventurer Jumping. And if I click on this, this actually is the sprite sheet. So that's what I am loading in at that particular point. And when it's loaded in, if I want to get access to that, I use the name Adventurer Jumping. Likewise with my spaceship and the true type font. So the audio wide font is available as well. So there, I'm using the asset manager to say, I haven't yet got these things loaded in. Here's their location. Go away, load them in please, and here's the name I'm going to use, or later other objects are going to use when they want to get access to it. So that's an example of how you can load in assets. For this demo, it actually shows different ways of doing it. The next one down here is where we go to our asset manager and we give it a JSON file. And the JSON file contains another bunch of assets that it's going to load in itself. So if we were to go down to the various textual files that we have inside assets, so asset demo screen assets, this is JSON here, and we open that up, we find that this JSON file says we want to load in 2 additional bitmaps, and that is the up arrow and the up arrow selected bitmap that you see alternating at the bottom. So inside here is 2 bitmaps. One is called, we're going to call it up arrow, and it gives the location image up arrow.png, so it's that one there. And the other one is also a bitmap, up arrow selected, and again it has up arrow selected.png. So either of those means either loading it in one by one, or putting them in a JSON file, loading them all in as a batch. They're perfectly legitimate ways of getting assets into your particular program. We have a bit down there about how do we actually get access to them then. So in this particular case, we're just going to get access to them immediately at the start, and we're not going to, you could do it each time you do an update, but because we know we're going to modify them in each update, we just get access to them at the start. So we go to our asset manager and we say, here, can I have a bitmap please? Here's the name of the bitmap I'm looking for. And asset manager will try to find it and store it in the actual mship bitmap object itself. We do that for the ship, the arrow, and the sprite sheet. And that's really it from the asset demo point of view. It shows you how you load assets in and how you get assets out. I'll go through the rest of this class because it just sort of shows you how we are displaying our assets. Update method then. We do a check at the start to see if the back button, if it has been triggered. In that sense, we remove this particular screen from our game manager. So we're peeling this one off. It'll go back to the last screen that we had on our screen manager, which is going to be the menu before this particular one. Okay, assuming then we don't have to go back, we do a couple of things. The first one then is where we have the bitmap at the bottom that is alternating between the two different variants. So it's the arrow down here at the bottom where it's displaying the ordinary arrow and then the selected arrow and then back to the ordinary arrow again. So this basically says, okay, I'm going to get a bitmap from my asset manager. Which one I get will depend upon the timing. If I take the total time and divide it by 2, I'm going to get it in terms of seconds if you like, and I'm looking to see if it is an odd or an even number. And depending on which it is, I will then either select the up arrow or the up arrow selected. The other one then, I'm going to do something similar over here. So I've got my color tint, which I will apply, and you'll be able to see it later on. I'm picking that from my array of colors. I'm looking at the time, and again, it's just checking the modulus of the number of color choices I have. So every second, we're going to go through and to change that too. Final bit I do there is that I take the spaceship, that image, and I increase the rotation of it. So basically, it works out how much has transpired, and then it'll be 10 degrees per second in terms of actually managing that as it goes around. If I do more in full iteration, I'm just going to take that back and then go back to, again, keep it in the 0 to 360 range. So that updates the objects in terms of getting the variation that we see. Draw method then, we clear the screen to white. To be honest, probably a bit unnecessary, but there you go. We get the width and the height of it. We create a paint. We got a color filter. We're going to need this here color filter because for a number of our bitmaps, when we're applying that color tint to it for the sprite sheet, we need to do this then using a paint instance where we have set up a filter on it. So the Porter Duff color filter, that's the one that gets a lot of control over how we manipulate our setups. In this case, we're going to use the multiply modification. So we will take our original bitmap values, the pixel values, and multiply it by whatever color we have. So if we had white, which in terms of multiplying it sort of 1, 1, 1, 1, it won't change it. But other ones, if we have a 0 in any of the channels, will effectively remove that color channel from the image. And we go for our bitmap paint because we'll use this when we're drawing out the sprite sheet. We say, okay, you should use a color filter to control how you draw things out. Source rec and destination rec, we're just simply setting this up for the sprite sheet to say that we want to draw all of the sprite sheet, so 0, 0 to the width and height of it. And we're drawing at a particular location at the top of the screen. And we're drawing out the sprite sheet with the two calculated rectangles using the paint, bitmap paint instance we created up here. That's the one where the filter is attached to. And that's why whenever we draw out these particular values here, we're not just drawing out the raw bitmap, we're applying that color tint to it. Next we have another paint instance. This is for doing our font. So we say create a new paint. We're going to set the typeface we want. We go to our asset manager and we say, can we have this particular font please? We set the height to be sort of scaled so it's a sixth of the height of the screen, and we want it to be centered as well. And then we simply draw out some text, bitmap some fonts, give it let's offset ever so slightly just so it looks nicer on the screen, and there's the paint instance to use. The last bit then is drawing out the rotating ship, and we're using a matrix to do this because if we have a matrix we can draw it out in a rotated manner. So we're creating a new draw matrix, slightly inefficient because ideally we should be reusing this matrix, not creating every single draw request, but there you go. We're setting up a rotation around the center of the image based on the rotation value we have, and then we're moving it to the location that's visible on the screen. And then we're simply saying, let's draw it out, that bitmap, manipulate it by that matrix, which contains a rotation and a translation. We're just going to draw the bitmap out as it is, with no tints or anything else applied to it. Arrow bitmaps, again, we draw that out simply at the bottom. Not really much to say about that. And we draw our back button as the last thing. So that's all that class does. It's reasonably straightforward, but it shows you how you can both load in assets directly or through a JSON file, and how you can get access to those assets through the asset manager. To wrap things up here, key points in this here is a game, so we will need to use lots of different types of assets to make this game come to life, if you want to put it that way. Images, sound, data files, whatever you want. Assets, they're generally speaking memory intensive. Because of that, we need some type of manager to make sure we look after these in an efficient manner. We don't want to have multiple copies of the same instance or the same bitmap loaded in, generally speaking. So we'll have an asset manager. Its job is going to be to load the things in and to keep a central copy, if you want to put it that way, where other objects can go to and get access to those assets if they want to draw them or play them or make use of them. The asset manager in GAGE is a very simple one. It doesn't do that much, to be honest. You can have much more sophisticated ones that get into load balancing, that get into streaming things in dynamically, freeing up resources, and again, quite an intelligent manner. But they're beyond the scope of the simple game that we have. So hopefully of use. Hopefully now you've got a bit of a better feel as to how you can load in and use assets within GAGE.